when we design an agent, the very first step is to carefully specify its task environment. Remember the vacuum cleaner world? To evaluate rationality there, we had to define the performance measure, the environment, the actuators, and the sensors. Together, this form what, as per the Russell and Norvik's textbook, is the PEAS framework or the PEAS framework. Performance, environment, actuators, and sensors. The PEAS description is like a blueprint. It focuses or forces us to think clearly about what success means, what the agent has to deal with, and how it can act and perceive. Let's consider a more realistic example like an automated taxi driver. The performance measures here will be what? The taxi should get passengers to the correct destination, minimize fuel and wear, avoid accidents, obey traffic laws, maximize safety and comfort, and ideally make a profit. Notice that some of these goals conflict. So trade-offs are inevitable. Next is the environment. The taxi must handle different roads, traffic, pedestrians, potholes, construction zones, even cultural variations, like driving on the right in the US versus left in the Britain or Japan. The more restricted the environment, the simpler the problem. But a real-world taxi must be very flexible. Third is the actuators. Just like a human driver, the taxi will need controls for acceleration, steering, and braking. It might also need displays or voice systems to interact with passengers, and possibly communication systems to talk with other vehicles. And the fourth is the sensors, or cameras to see the road, possibly LiDAR, radar, or sonar for detecting distances, a speedometer, accelerometer, GPS for navigation, engine and fuel sensors, and microphones or keyboards so passengers can give instructions. So PEAS is not just an acronym, it's a practical checklist. By explicitly defining performance, environment, actuators, and sensors, we give ourselves a foundation to design, evaluate, and compare intelligent agents. So there are different properties of task environments which we need to know. So there are multiple PEAS solutions with some examples which have been shared here for different intelligent agents. And let's move on to the place where we talk about properties of environments, which is very important. When we design an intelligent agent, we also need to think carefully about the type of the environment it operates in. Russell and Norvig identify several important dimensions. The first one is fully observable versus partially observable. If sensors give the agent complete information about the world, then the environment is fully observable. If not, let's say, for example, a vacuum robot that only knows about the square it's in, then it's partially observable. Most real-world environments like taxi driving are only partially observable. Another is deterministic versus stochastic. In a deterministic world, actions always have predictable results. In stochastic environments, outcomes are uncertain, like traffic or mechanical failures in a taxi. Many real environments are uncertain because we can't observe everything. Then we can talk about episodic versus sequential. In episodic tasks, each decision is independent, like classifying images one by one. And in sequential tasks, current action affect the future, like chess or taxi driving. What about static and dynamic? In static environments, the world waits while the agent thinks or ponders about what actions to take. But in dynamic environments, the world keeps changing, like cars moving while a taxi intelligent agent decides. Chess with a clock is semi-dynamic. That means the board doesn't move, but the time matters, so time moves. Next is the discrete versus continuous. Chess is discrete, like finite states, discrete actions. But taxi driving is continuous, like position, speeds, and steering angles change smoothly. Next one is single agent versus multi-agent system. So in a crossword solving agent works alone. So it's a single agent system. But in chess, two agents compete. So that's a competitive multi-agent environment. Driving a taxi is multi-agent too. Sometimes cooperative, like avoiding collisions helps everyone, and sometimes competitive, like fighting for the same parking spot. Okay. So these are a table with where you need to fill the characteristics of different environments, and you can try it by yourself.